Credentials you deployed years ago may already be compromised, and nobody told you. Today we're analyzing how Google's introduction of the Gemini API silently turned every unrestricted API key into an authentication token for sensitive AI endpoints. This isn't theoretical, it's already happening. This is part 3 of our Legacy Trust in the AI Era series, and the design pattern we uncover here goes well beyond Google Cloud. We've structured this analysis around 5 areas. First, the escalation pattern, and why your team is probably not scanning for it. Then, the 4-step attack chain that turns a billing identifier into full AI endpoint access. After that, 3 assumptions in your threat model that this disclosure just broke. Then concrete remediation you can act on right now at 3 maturity levels. And finally, the design lesson that outlasts this specific vulnerability. The pattern has a name, and once you hear it, you'll recognize it everywhere. It's called Ambient Credential Escalation through Platform Capability Expansion. In plain terms, that's when enabling new capabilities on a cloud platform retroactively expands the scope of every credential already deployed in environments you don't control. Here's the scale of what we're dealing with. When Google enabled the Generative Language API, that's the Gemini API, it silently granted Gemini access to every existing unrestricted API key on those projects. No email, no console alert, no notification of any kind to the people who had deployed those keys. Truffle Security's research published February 25, 2026, found 2,863 vulnerable keys just by scanning public websites through common crawl data. But that's only the web. Quokka, a mobile security firm, took a different angle and discovered over 35,000 unique Google API keys embedded across 250,000 Android applications. And here's where the financial reality hits. A single compromised key generated $82,314 in Gemini charges over just 48 hours. That's the cost of a credential that was deployed following Google's own guidance that for over a decade said these keys were not secrets and were safe to embed in client-side code. So what exactly happened, and why does this pattern persist? On the what happened side, Google API keys default to unrestricted project-wide scope at creation. When anyone with access to a project enabled the Gemini API, the platform automatically expanded every key's access to include Gemini endpoints. And critically, no notification was sent to key deployers. If you had embedded a key in a website or mobile app years ago, your key quietly gained full Gemini access without you ever knowing about it. Now, why does this persist? Because the platform was optimized for the developer who creates a key, not the developer who deployed one 3 years ago and moved on. Unrestricted defaults minimize configuration steps at key creation. Silent inheritance avoids confirmation dialogues when new APIs are enabled. And credential scope is bound to the project, not to each individual key. There's no mechanism to say this particular key should not gain access to future APIs. The system was designed for developer convenience, and the security trade-off was never revisited when sensitive AI services arrived. Understanding the pattern is one thing. Watching it play out against real infrastructure is another. The attack chain has 4 steps, moving from a publicly exposed billing identifier all the way to AI data exfiltration and silent billing abuse. Step 1 is credential harvesting. The attacker grabs an AIZA key, that's the Google API key format, from a website's page source. A decompiled Android APK, a public code repository, or even common crawl web archive data. Remember, for over a decade, Google told developers these keys were safe to embed publicly. Thousands of them are sitting in plain text right now. Step 2 is site privilege escalation. This is the core of the vulnerability. When someone on the keys project enabled the Gemini API, the platform had already expanded that key's scope to include sensitive AI endpoints. The key deployer was never notified. The key itself didn't change, but what it could access changed fundamentally. Step 3 is exploitation. The attacker calls the Generative Language API endpoint with the harvested key and receives a 200 OK instead of a 403 forbidden. From there, they can access uploaded files and datasets, cached context, including proprietary prompts and RAG documents, and generate billable inference at the project owner's expense. Step 4 is sustained abuse. Without billing anomaly alerts, the attack just keeps running, silently at scale, until someone notices the charges. Let's talk about the money. That $82,000 figure isn't hypothetical. It's a documented case where a single compromised API key generated $82,314 in Gemini charges in 48 hours. And here's what makes this particularly dangerous. Without per-credential consumption controls, There's no mechanism to cap a single key's charges. The billing just kept climbing. This isn't just about one bad key. Google AI Studio auto-creates GCP projects with unrestricted keys when developers sign up, meaning people who just wanted to try Gemini may have unknowingly created projects with publicly exploitable credentials. They may not even know the project exists. Without billing anomaly detection, without per-credential consumption controls, and without proactive notification from Google, the math favors the attacker. Every hour that passes without detection is another hour of billable inference charged to your account. And without a per-key consumption ceiling, a single compromised credential can run up charges until the billing account hits its limit. So with that financial reality in mind, let's step back and think about what this actually changes. Because the bigger story here isn't the dollar amount. It's the assumptions that broke, assumptions that many of our security programs are still built on, and which ones were wrong from the start. 3 foundational assumptions broke with this disclosure. The first, that API keys are billing identifiers, not authentication credentials, and therefore safe for client-side code. In reality, these keys silently became AI authentication tokens the moment Gemini was enabled. What was a billing identifier on Monday became a sensitive credential on Tuesday, without the key itself changing. The second assumption, that enabling a new API is a non-destructive administrative action. It's not. Enabling the Gemini API retroactively escalated the privilege of every unrestricted credential in the project. An action that felt routine fundamentally changed the security posture of every deployed key. And the third, that deployed credentials retain their original scope indefinitely. They don't. In a project scope credential model, a credential's capabilities are defined by whatever services are currently enabled, not by what existed when the credential was created. Add a new service to the project, and every credential's scope expands automatically. No rotation, no reissuance, no notification. The scope changes without the credential itself ever changing. If you're wondering whether this is a niche problem, it's not. This pattern hits 6 categories across 3 different OWASP frameworks. It's not a single bug, it's a design pattern failure that shows up at every level of the security taxonomy. Starting with the OWASP Top 10 2025. AO6 Insecure Design. Keys default to unrestricted scope by design, not by a bug. And AO2 Security Misconfiguration. The unrestricted default is a textbook insecure default that ships to every customer. From the API Security Top 10, API 1 and API 5, broken authorization at both the object level and function level. The Gemini files and cached contents endpoints accepted keys that were never intended for AI data access. And from the LLM Top 10 2025, LLM 02 and LLM 10, sensitive information disclosure and unbounded consumption. To put it plainly, the same key that generated $82,000 in charges hit 4 of these 6 categories simultaneously. This isn't one failure mode, it's a design pattern failure that spans 3 OWASP frameworks. You've seen the problem. Now here's what you do about it. Our remediation roadmap is tiered by organizational maturity, from immediate key restriction that you can start today, all the way through building a strategic assumption inventory. Our remediation covers 3 tiers, scoped by organizational maturity. For well-resourced teams, start immediately, restrict all API keys to specific APIs across every GCP project. This is the single highest impact action. Then run Truffle Security's 3-step audit. Check every project for the Generative Language API, audit key scopes under credentials for unrestricted warning icons, and verify none of those keys are publicly exposed. Start with the oldest keys, those are most likely deployed under the old not secrets guidance. For mid-maturity teams, the short-term priority, implement a credential impact review gate in your API enablement workflow. Before enabling any new service, require a check of existing key scopes and deployment contexts. Set up billing anomaly alerts on all projects with Gemini enabled. Strategically, for all organizations, build a credential assumption inventory. Document what each credential can and cannot access, and tie review triggers to platform change announcements. For GCP organizations, enforce key restrictions at creation through organization policy constraints. Those 3 tiers cover the one-time work, but here's the part most teams skip: make it recurring. Audit key scopes against your current service catalog on a regular cadence, and validate that your credential security assumptions still hold. The review cadence should match your platform service catalog evolution. Now, the harder question. Which defenses would have actually stopped this before it started? The highest confidence defense. Default keys to restricted at creation, with no APIs enabled. If keys started with 0 access, and only gained scope through deliberate grants, the entire silent inheritance problem disappears. This is a platform-level change Google has not yet made, but it's the one that would have prevented the vulnerability from existing in the first place. The second defense, medium confidence, a confirmation prompt at API enablement. If your project has unrestricted keys, the administrator sees a warning before proceeding. Enabling this API will grant Gemini access to N unrestricted keys. Google doesn't currently surface this, but alerting when unrestricted keys exist would catch most cases. The third defense, billing anomaly detection with automated key suspension. The $82,000 case ran for 48 hours without triggering any alert. A consumption threshold tied to per-project baselines would have caught the abuse before charges reached $82,000, though new projects without usage history wouldn't benefit. If your team had asked these questions before this disclosure, you would have found the risk. Here are 6 to run against your threat model right now. On the credential audit side, when you enable a new API on a cloud project, do you audit which existing credentials gain access? Are any of your API keys still set to the platform default of unrestricted? And do you track which keys are deployed in untrusted environments, client-side code, mobile apps, public repositories? On the platform awareness side, does your threat model account for future API enablement, changing the scope of existing credentials? Do your billing alerts catch AI inference abuse within hours, not days? And here's the one that matters most. Your security program probably assumes that API keys are not secrets. When was that assumption last validated against your current platform capabilities? Here's the design lesson that outlasts this specific vulnerability. Credential scope must be explicitly bound at issuance, not inherited from the environment. That's the design principle this disclosure proves. When you create a credential, it should access nothing until you deliberately grant it access to specific services. Zero trust applied to credential creation itself. The corollary is equally important. Platform capability expansion is a credential impacting change. When a vendor adds a new AI service to your cloud account, that's not just an administrative action. It retroactively changes the security properties of every credential in the project. Your threat model needs to treat it that way. And this means organizations need assumption inventories for credentials. Not just what each credential can do today, but what it was assumed it could not do when it was created. When the platform changes, those assumptions need to be revalidated. The teams that build this practice into their credential lifecycle will catch the next ambient credential escalation, whether it comes from Google, AWS, Azure, or your own internal platform, before it becomes an $82,000 surprise. All references and source links are available in the full article on dcicyber.com. Now you know what nobody told you about those deployed credentials. The full analysis with all references is on dcicyber.com. If we helped you rethink credential security, subscribe and hit the bell. We publish new cybersecurity deep dives every week. What credential assumptions is your team still carrying from before the AI era? Drop it in the comments, and stick around. This same ambient escalation pattern shows up in other cloud providers too. That's coming next. Thanks for watching. See you in the next one.